We're going to do some more area problems today. And today we're going to set up these integrals in terms of y instead of in terms of x. And this first problem is the last one that we did on the last worksheet. And we saw that this one was a little messy because we had to break the integral up into, or the area up into two regions and do two separate integrals. So let's draw this region again and then talk about y. So natural log of x looks something like this. And then y equals x plus 4. That should be negative x plus 4. Looks something like this. And so we have a little region down here. And so when we were integrating this in terms of x, we think about rectangles that look like this. And we saw that up until that intersection point, the natural log is my top function and the x-axis is my bottom function. But then we switch top and bottom functions. And so we had to separate this into two separate integrals. What I'm going to suggest that we do now is, instead of drawing vertical rectangles, draw horizontal rectangles and see what happens. So if I draw horizontal rectangles, we see that the red function is always on the right and the black function is always on the left. And so if we do things with horizontal rectangles, we always have the same thing on the right and always have the same thing on the left. So maybe this works better. If we're using horizontal rectangles, then we're going to do things in terms of y, because what we're thinking about this is a little bit of a change in y instead of a change in x. And then the height of the rectangles will be this direction. So the width is that change in y, the height is the distance kind of in the y direction. So what we're going to do here is, if we're using horizontal rectangles, we always integrate in terms of y. So my integral is going to have a dy at the end. I need y values for my bounds. So my bottom y value will be 0. And my top y value will be whatever y value we get here. You can look at Desmos or some other graphing function and find that that y value is 1.074. When we do things in terms of y, we're going to do right function minus left instead of top minus bottom. So my right function in this case is the negative x plus 4, but we need to rewrite that so it has y's in it instead of x's. So I can add x over and subtract y, so I get x is 4 minus y, so that's my right function. And then my left function is ln of x, but again, I need that as a function with y. So if I solve this for y, I use e on both sides, so I get x is e to the y. So this is my integral that I set up to get that area. We notice this is a little nicer than what we had to do last class because it's a single integral. And a single integral for a single region, that seems like a good idea. So why don't you try this one? You might need to graph this in Desmos, but y squared minus 1 is a sideways parabola. It opens this direction and is shifted over 1. So this is my y squared minus 1 is equal to x. That's already written with a y is equal to x, or like y function is equal to x. So we'll probably do this in terms of y. X minus 2, that is a line down here. And so the region we're looking for is this one here. So this again definitely looks better to do in terms of y, because if I do this in terms of x, I actually run into a big problem here, is that my top and bottom function are the same functions, which is a really bad idea. And then over here, the top and bottom functions change. So let's do this in terms of y. If I do this in terms of y, red function's always on the right, black function's always on the left. So when I set up this integral, I'm going to have to figure out the bounds in just a second. So let's do that in a minute. If I solve this one for x, I'm going to get y plus 2 is equal to x, and that was my right function. So y plus 2 is right. And then this guy was my left function, so right minus left. Make sure you put your parentheses around that y squared minus 1. We'll have a dy at the end here. We need to find the bounds. So we need to find what is this y value and what is this y value. Again, do that in Desmos or on your favorite graphing calculator. If you don't know how to find those intersection points, if you type both of these in Desmos and then just click on those intersection points, it will give them to you. If you can't figure that out, let me know in class. And we're looking for the y values now because we're doing everything in terms of y. So this y value is 2.303. So we put that up top. And the bottom one was negative 1.303. You could probably solve this one by hand. This will give you a quadratic formula if you set this equation and this equation equal to each other and solve for y, but it's okay to do this one in Desmos.